Okay. Can you just open for me the link to see like what's...
I was just doing that.
Okay.
It's working.
It's working?
Yeah.
Okay. Meet, yeah. So let's see. So if you want. Okay, so I suggest to start and maybe. So I suggest to start, and in the beginning, I have like a little bit update what was happening in Azure during July. So this will give chance to some people to come before we start the main topic. And just before that, can we check that? Do the people hearing normally over the broadcast? Oh, it's okay. I heard my voice. Okay. Welcome. Good evening. Okay. So let's start then. Okay. So from last time, we started with a little bit a new scheme, how we manage this event. In the beginning, I want to give like a very quick overview what happened with Azure during the last month, because actually Azure is developing so quickly, so it's very, very difficult to keep with the pace. This is not Azure, this is also AWS, Google, so there is so much innovation that it's very, very difficult to keep with the pace. So I'll go very quickly over some updates. The idea here is to point you for some events that are maybe interesting and relatively important for your business. And then you can go and get into more details, or if you need more information, please ping me and I'll try to find a good point of contact for you in Microsoft. Let's start with the first one. We have like a general availability of IS classic virtual machines to resource manager virtual machines. There is like a standard way of doing that thing coming from the platform. For storage, we have a general availability about Azure Cool Blob storage in Canada. So Azure Cool Blob is a cheaper version. I think there is already equivalent on AWS. Basically, you pay less for not so active data that you don't need every day, but potentially you need, let's say, few times in a week or per month. So this is generally available, backup by SLAs and everything that is required to be used in production. Next one, Azure Redis cache updates. Now we are able to reboot the instances of Redis cache from the main portal. This is very interesting. For example, when you want to see like what will happen in a disaster scenarios when your Redis is down, how your application will behave. And also you can schedule updates again from the UI. Azure Automation. With automation, you can schedule different events. Now, this functionality actually supports different time zones and also daylight savings, which is a little bit tricky if you have a business in different locations around the world. Always encrypted for Azure SQL database is generally available. This means that one more step towards more secure solutions for your data. So basically now with Azure SQL, you can have like your data encrypted at rest and also over the wire. So very secure storage of your data. For Azure Active Directory, we have like update for the PowerShell commandlets. And Express Route available in 3 new locations: Paris, Newport Wells, and Quebec City. Another new things are we have 2 new regions in US, West US 2 and West Central US. We also have general availability of SQL Server Stretch database. This is very interesting offer, allows you to run your SQL database on-premise, but also to put some of the data in the cloud. So let's say that you have enough space on your servers on-premise and you have one, for example, have like disaster recovery, you can push part of the data to the cloud. Microsoft Power BI embedded. This is very cool. You can have like a Power BI dashboards embedded in your web solutions with very powerful, basically the same capabilities that you have in the Power BI product itself. Although you have to be a little bit careful, we plan to implement this thing in our web solutions. And after a lot of conversations with Microsoft, turned out that the people who can use this Power BI embedded actually need to have like a Power BI Pro license. If you're talking about inside company scenarios, like in-house scenarios. I think the big push for this feature is to have to attract new users. If you have like a internet website that is accessible for your customers, then it's a very good offering. But if you want to use it in your enterprise, you have to be careful like what kind of license your users have. And from September, they will announce a new type of license that will be based on per rendering and also per session. So it will be a little bit more flexible. So Microsoft R service, R server for Linux virtual machines is available. Yeah, Microsoft R server is actually a solution that Microsoft acquired from a company, I forgot the name, but basically allow you to use to work with the R programming language, which is the leading language for statistics, and also has a lot of applications in machine learning. Microsoft introduced AppSource. AppSource is a kind of repository for different SaaS business apps. So based on your enterprise interests, you can go in this website and find a partner of Microsoft or Microsoft Core Service that you can use as a SaaS provider. Cortana Intelligence Suite with Bing Predicts. It's in a public preview. This is also a very interesting offering. Bing Predicts basically leverages all the data that Microsoft has access to from Bing, from Windows, from various devices. And based on this data, you can predict interesting things about your business and different trends in the society. So I definitely advise to look into this thing. Azure IoT Hub S3 edition is available. This allows us to send up to 300 million messages per day. So new, better solution with high throughput. General availability for Bing APIs with Microsoft Cognitive Services, spell check, auto suggestion, and speech APIs. Microsoft R Client is a solution that allows you to connect to Microsoft R Server and also to work with raw data in the context of R. G-Series of virtual machines are available in Australia East. Azure SQL Data Warehouse. Good evening. Azure SQL Data Warehouse has a general availability. Definitely very interesting solution for high throughput scenarios and for warehouse type of workloads. Azure App Service Authentication with Azure AD Domain Hints. So here, very long title, but what actually this helps you to do is to, for example, forbid non-organizational accounts for your employees when they're using Azure Active Directory to log in applications. So basically specify the domains that are supported from your web apps when the user authenticated. So this is very interesting a feature in the context of enterprise. One more slide. General availability for service bus premium messaging. So the idea here is that with premium messaging, you have dedicated environment for you, and you have like a lot more. You can predict the performance of the systems, and you can have very reliable messaging. Azure DevTest Labs. This is also a great feature. Allows you to control environment in Azure and to provide this as your colleagues or your team. And basically, in the end of the month, to avoid any surprise that you get very high bill from Azure, you configure Azure Dev Test Labs in a way that is acceptable for your organization. You define limits. You define what the users can provision in these Dev Test Labs. But you give the freedom of your team members to create the resources and start operating very quickly. So now you can attach data disks to your lab VMs. And something that is very interesting for me, this is the general availability about portal updates from Stream Analytics. Now with Stream Analytics, which is the platform for analyzing streaming data coming to Azure at very large scale, you can output the data to Power BI, and this is general availability now, Data Lake, and sorry, here I have a mistake. I think it's a sample input. But the idea here is that Power BI is very important because it allows you to actually project your data in a dashboard. So your business stakeholders immediately can see trends. Data Lake is also very, very interesting option. Data Lake is this data store in Azure that is built for very parallel computing. In the same time, you don't have any limitations in terms of the size of data that you put or the number of the files. So it's a very powerful solution for big data scenarios. And this is it. This is like a very quick run across the latest updates of Azure. But please, if you find something interesting for you, go and check the details and let me know if you're stuck somewhere and you want to learn more. So with that, I want to start today's talk, which is dedicated to serverless architectures and Azure functions. So this is very exciting topic, and please, if you have questions, let's make it very interactive. Stop me and let's discuss. I have a lot of material to cover today, but the most important thing is that you understand and take something important from this talk. So please don't hesitate to stop me and ask questions. So very quickly about me, I'm Azure MVP, also architect, and I participate in Azure Advisors Forum, where we talk with the product teams and try to find a better solutions and a better shape for upcoming Azure features. I run Tokyo Azure Meetup, but this is not my meetup, this is our meetup. So please, if you're interested in a topic and passionate about the topic that you want to present, please come and take my place. I'll be very happy. Taiki did a great job last month. So please, the topic just has to be related somehow to Azure. But Azure is so broad these days, so this is actually a very easy task. And these are my contacts. Okay, so let's start. Serverless computing. So first, there is different ways of talking about serverless computing, but one very simple way of describing it is when we talk about serverless computing, we want our developers stop thinking about infrastructure. They just forget that there is a server. Of course, behind the scenes, there is always a server, but this is not anymore concern of our developers or ops people. And why this is important? Actually, it's important because if it turns out to be as powerful as I think and other people think, this probably will be a next big change in the cloud computing. Because it will allow us to focus again mainly on the core logic, our business differentiator, instead of investing time in building infrastructure and supporting our systems. So the big focus here is on application code, on our features, how we build our solutions and how we make them really competitive from day one. And something that is also very important is the cost effectiveness. We'll dig deeper in that later, but this is the cheapest way that you can run today in the cloud and take actually what you need. Basically, you pay only for what you use, and we'll see that what we use is really what we use. It's not like a lot of people are thinking that, for example, when you use PaaS, you're paying less. But now today we'll compare like how PaaS compares with serverless, and really there is a huge difference. I'll show you my subscription, and it's obvious. So Let's dig a little bit deeper in and look what was the brief history of cloud so far. So first we start with the data center. This was the abstraction, right? So at that point, the hardware was our scale unit. And we actually didn't have so much abstraction to start with. And then we moved to infrastructure as a service. So then our scale unit became the operating system. And what was hidden from us, this was actually the hardware that is running this operating system. Then the next interesting transformation came from a platform as a service, where we actually were scaling applications, and everything else from operating system and below became abstraction, and we didn't care anymore. And today we are entering a new phase, which is serverless, where our unit of scale is just a function or very small application code, and everything else is abstraction for us. And this is very powerful. It can be challenging, but in the same time brings a lot of advantages. So for me, this is also very much connected with the other main trend currently, microservices. So here you can see on this slide, on the left side, we have this typical monolithic system. You can think that this is e-commerce solution, which has the usual things, recommendations, inventory, shipping, orders, and everything is built in a one big chunk, right? The problem with that is that for every single minimal change, we need to redeploy the whole single monolithic block. And this is challenging because we need to test for regressions, we need to organize complicated and very careful deployments to our production workloads. So the industry is shifting to microservices, where we break the functionalities in smaller pieces that are developed and deployed independently. So when we talk about microservices, there are many definitions, but one that I like is small autonomous services that model business domain and in the same time have a single responsibility. The single responsibility is actually one of the most important things, but also they should be small and they should be autonomous. So as you can see here on this slide, on the other side, we have each of these main features divided in a separate and dedicated services that we can build independently, deploy independently, and manage independently. For the user that is accessing, that is going to our app gateway and maybe browsing our website or using our mobile app, the experience should be the same. But for us, behind the scenes, we have a lot of advantages from this model. So the question is how we can improve that. What is the next step? The next step is actually to break these services that we have in green in smaller chunks, to break them in functions. So for example, here we have the order microservice. So order microservice is doing only one thing. It's dealing with the orders in our system. So now we want to say, okay, order microservice, but I want to manage actually each of the different methods that this microservice supports independently. So for that, I can break in functions. So I'll have one for getting the order, another one for creating, another one for modifying, and another one for probably deleting. And they'll be hidden by API gateway again, and my mobile client will be able to access them as usual. The advantage for me is that if I want to change the update order function, I don't need to think about the rest. Of course, you have to make a trade-off because you're breaking the logic. So you probably have some kind of duplication, and we'll talk a little bit later how we can avoid that. So let's talk a little bit what are the main principles of serverless computing and serverless architecture. So the idea is that we completely abstract the underlying infrastructure. So when we write code, we shouldn't think this code will run on this very, very special server, on this very, very special virtual machine. No, this shouldn't be the case. And also we need to think what is the most efficient way to model our business domain? What are the granular pieces that we can break the logic into? And we should focus only on the application code, nothing more. The advantages that are coming from the platform is that we are getting the control to scale. Basically, in seconds, our functions or our application blocks can scale rapidly. And you can correct me after that. This is true or not, we'll see. Ideally, this should be the behavior. And also another big thing that I see a lot, especially with the serverless type of applications, I think you'll see the trend later in the slides, but this serverless approach is actually allowing us to glue together multiple systems in a complicated workflows. So one of the kind of patterns that evolve from the serverless approach is that you start to work with a lot of external systems, and you start to rely with a lot of external systems because your logic is so minimal. It's just like a few lines of code, up to maybe 100 lines of code, so you cannot do much inside. But if you call external services, then you can actually achieve the same things that you're doing before with monolithic type of system. So let's see what's the current state. So obviously, I think the different notions, like which company actually started the serverless revolution. But in my opinion, people start really to consider it seriously after AWS Lambda was released, and there were like a lot of solutions built on top of it. Also, Auth0, they have their platform web stacks for some time. So they're also one of the pioneers. Google released Cloud Functions, and today we talk about Azure Functions that is currently in the preview. So all of the above have open source elements. I'm not completely sure about AWS. Are they open source?
I don't believe so.
No, they're not. Azure Functions is built on top of WebJobs SDK, which is open source. Auth0, not completely sure, but the only really completely open source solution is IBM OpenWhisk that currently you can use in Bluemix cloud that they manage. So basically, these are one of the main players, but around them, there are actually a lot more. So there was like the first serverless conf in New York in May, where there were like multiple providers presenting their solutions. So there are like different people building frameworks, there are people building solutions. So I think in the next 1 year, we'll see a lot of people trying to become the leaders in the space. But now when we have like actually the four major cloud providers with established offerings, I think probably this will be the leaders for some time. So I also want to pay a little bit attention about the operations. So currently today, there is a lot of hype about movement called DevOps, where we shouldn't care only about our code as developers, but we should think from end to end. We should think how our solutions are deployed to production, how we can maintain them, how we can fix them in a real scenario. So basically here, the notions, all of these bullet points say one thing, like you or we as a software engineers, we are also responsible how our system behaves in a production environment. So it's not just enough to come up with a smart way of implementing a business functionality. Most of the time we have a pager or we have a pager duty, and if our system is down, we'll be called during the night. So the notion of the idea that we are only developing, I think is quickly going away. We are now responsible for the system all the time. And I think this is a pattern that was first introduced by Amazon and maybe other companies before that. But I see it now as a trend. I also have a pager duty. If my system is down, I'll be called. So the shadow side of this DevOps experience is that the software engineers need to acquire new skills, ops skills. So I can share my experience. Like in my team, we want to adopt DevOps. Developers actually think they're losing time instead of developing features. So I'm not sure like what is the right approach. Should we upgrade ops people to be our DevOps people, or we should target like our developers to acquire additional ops skills? So this is questionable, and maybe you can share your experience. But the one thing is for sure like DevOps is important part of for managing our systems. And yes, we need to build like excellence for maintaining our systems, and also get a lot of metrics and be sure like how our system behave in every single moment. So why I was talking about DevOps, because this is one study that actually shows what are the major blockers that prevent innovation in the enterprises. And the single one that is confirmed for 2 years, 2014 and 2015, and actually 2015, the percent is increasing from 36 to 42, is development time are too long. So this means it takes too much from the time that you start developing feature to releasing it. And people start to ask questions why. And when you partition your development process, you see that one of the issues is also DevOps. Because you're spending time automating your infrastructure and so on and so on. So the idea is that people are slow to move to production, and this is costing them money because the competition is already over there and is attracting some of our clients. So this is actually one of the advantages of serverless architecture, because we significantly reduce the operation cost of our solutions. Now, we'll see now with Azure Functions, but actually, the only thing that you specify and that you have control over Azure Functions is to say like what should be the memory for your functions as a container. But what's going on behind the scenes, it's a complete black box for you. So this is advantage because actually you don't need to invest so much time to think like how to improve the solution. It can be disadvantaged if you want to have something that is not available from the platform, but we'll talk about that a little bit later. So here we are the advantages. Like first, we have like a rapid development. We are a lot faster with serverless, especially after we learn how to do it the right way. Second, we can be truly polyglot. This means that it's okay to have like a part of our solution implemented in Node.js, another part in C#, another part in Python, another part in a PowerShell, let's say. And all this can be actually presented as one API to the outside world. But inside, we can be very flexible and use the right tools for the right task. Also, it's event-driven. This means that our functions will be executed only when this is required. So they will not spend money staying over there as idle resources. We have minimum maintenance, and also the platform are built like this to be very scalable. And we just pay for what we use. So the disadvantages. We have like a limited view what's going on in the platform. So even in this serverless conference that was in May, people weren't sure like actually how AWS Lambda works. And for the first time, maybe this was a little bit open. They shared their containers that are automatically provisioned. But cloud providers' point is you shouldn't care, and you shouldn't know, and you shouldn't ask. But in the same time, when your clients ask you questions, you say, I don't know, and this is not very good, right? So there is some kind of trade-off that we have to achieve. Also, another problem is, we see it with Azure Functions, but I think this is also the case with AWS Lambda. We have still not so mature tooling around it. So we need to be smart and to overcome these limitations. And just remember, all these things that we're talking again, this is very young. I think, correct me, when was released?
Less than 18 months old.
Yes, so this is like a year and a half, right? And functions are not released yet. I think Google Cloud Functions are released. I'm not sure is it reviewed yet. Not yet? Yeah, so everything is very, very young, but the potential is huge. So I think it's very important that we start thinking, start playing a little bit, and start planning. So also there, because it's so new, we don't have like best practices. There are a lot of people who are concerned about security, about penetration testing, about sharing resources. So this is some kind of mystery currently. We really need to do a good job to push the cloud providers, Microsoft, Google, Amazon, to explain us more like how we should do it right way. Because when you don't see how it works, you don't know how to do it right way. And I really advise you, currently there is no videos from this serverless conf, but there is at least the presentation and a little bit of blog post around it. Over there, a company called Nordstrom, they were trying for 18 months to go completely, or some of their solutions to go completely serverless. So they were facing a lot of issues. And they said, like, if we knew the information that we know now, will save us maybe half of the time, because it's a lot of trial and error at a point. And the biggest thing that I see is a lot of people are very, very much concerned about the vendor lock-in. This is avoided only with IBM OpenWhisk, but apart from that, each of these platforms, basically you're completely hosted in the cloud environment they provide. It's very difficult to move the system on premise, because you don't have the same system that will auto scale in seconds. So I think this is again a trade-off that you need to make. And also there is a lot of information about limits. We'll see about Azure Functions as well. We don't know exactly what are the metrics based on which they scale. Of course, we know it's a traffic, it's a CPU, but what is actually the algorithm, we don't know. So let's go and look a little bit deeper in Azure Functions. So what are Azure Functions first? Basically, how the team explained this, there are like three main elements: input, code, and output. Very simple, right? So we have some kind of input that is activating our code. Our code executes, and after that, it reports output. And we have a lot of options for input and output. There are two main terms that we need to remember in terms of functions. These are triggers and binders. They're coming actually from SDK, which is called WebJobs SDK, that we'll talk soon about. But basically, the trigger is the thing that allows us to invoke our application code based on certain rules. And then we have the binder that allows us to bind our parameters to external services and to make it really smooth and easy to get and output data. So as I mentioned, like Azure Functions is a natural evolution of a WebJobs. So if you already use like an Azure PaaS, there is like a very good solution which is called App Service. And one of the App Service offerings is called like a web app. In a web app, you can run like a background processing with a WebJobs. WebJobs are basically command line tools, like executable, that have very good integration with the storage, very good integration with the scheduling mechanism. And pretty much this is it. Allow you to do like an interesting thing behind the scenes. So for example, if you have a website that allows you to upload pictures and you want to resize these pictures on upload, you'll not do it you'll not do it on the main thread, you'll not do it on your front end. You'll give instructions to your web job to resize the image for you when it's ready to upload it in a certain place. So all these like a background type of processes, like a long running operations, you should do with WebJobs. So before that, probably you were using cloud services, worker roles for that. But this is very lightweight and very interesting and very elegant to operate. So the advantages of WebJobs is very extendable. You can run it anywhere. The disadvantage is that actually there is no very well-established HTTP functionality. So you can run it based on events on a storage queue, on a schedule basis, but you cannot trigger it by HTTP request. On the other hand, we have functions. Functions expose all the functionality that we have on WebJobs, but it's actually on steroids. It provides a lot more. So first, you have a lot more languages. Second, it's completely managed dynamic scaling. So based on your traffic, it will scale for you dynamically. We have a portal experience that makes the development very easy. So what are the disadvantages? currently we cannot customize the host where the function is running. We don't have the control. We don't access this thing at all. We also are running in the context of different applications, so we need a little bit to set up our continuous integration, our like Git repositories, and so on. And currently the tooling is a little bit behind, but since it's a preview, this is acceptable. Hopefully, actually, I think Azure Functions has a pretty good chance maybe to have the best tooling from all of the serverless architectures. But let's see what the team will do. This is a very interesting slide. This actually shows us how Azure Functions integrate with the different Azure services currently. So if we start from the beginning, we can schedule Azure function. This means that based on a schedule that we define, the function will be triggered every 5 seconds, every 5 minutes, every 5 days. Also, we can basically trigger the function through a webhook or REST call. This is very powerful, allows us actually to create like a big and very complicated, complex workflows, combining different services together. Then also we have storage. Storage is actually has the best integration. It supports triggering. This means that when like a blob storage, we have some kind of event on a blob storage. Let's say we create a new blob store. We create a new blob. We can trigger our function. Also, we can get input from a blob store, and also we can output to a blob store. Blob. Events, Event Hub, we can trigger and we can output. Queues, similar situation. Tables is very interesting. So tables, do you know, guys, like, why we don't have like a triggering mechanism for tables? What's your guess? Why tables cannot trigger the execution of Azure functions? What do you think? Queue can, blob can, table cannot.
Question about the queues though, real
Yes.
fast. If the queue uses a trigger, can we read the content of the message that triggered it? So it's in effect like an input
Yes.
that we can map.
Yes. Here it's a little bit. I was a little bit also confused on that thing. I think here the meaning is more like it triggers, but it cannot be used only for input. Every time it should trigger. That's the. And here about the tables, actually the team, they were very open. Currently Azure Tables, there is no like event like when you add a row in Azure Tables, basically Azure Functions cannot get a notification on their side to actually execute the notification. So this is like a limitation on Azure Tables. It's not something that Azure Functions are so much concerned. And this is interesting how they are solve it in the future, because this interesting scenario. Azure Tables are very, very interesting tool. So going down, we have support for tables that are part from mobile apps. We have support for DocumentDB, and we have support for Notification Hub. So as you can see, like a very good list of services. And my guess is this list will grow with time. So now let's go very quickly on a concept level on a few scenarios that you can address with Azure Functions before we go to the real examples and demos. So this is like an example for time-based processing. So every 15 minutes, we want to find and clean invalid data in our table and basically clean the table. So it's that simple, right? You just define a schedule, you define a condition, what is invalid data for you, and need to execute for you. You don't need to have an API. You don't need to have another API to call this API. I think it's very, very good pattern. Next one. Event processing. So this is a little bit what I mentioned before. We added a new blob file to a storage account. We subscribe for this kind of event. When we have like a blob uploaded to a container that we are subscribed to, we can trigger our function. So in this case, we'll take the CSV file and we'll transfer it to a data row. And after that, it will be shown in a Power BI chart graph that the database is connected to. Another one that is very interesting, starting working with the SaaS providers. Here, this is OneDrive, but it can be a lot more, because Azure Functions work very well with logic apps. And logic apps work with a lot of these SaaS providers, like a Yammer, email senders, SendGrid, Twilio, and so on and so on. So you can enable very powerful scenarios. So again, something is happening to your OneDrive. For example, you're uploading Excel file. You can create a function that will do something with this event and this information. So let's say it will send you an SMS, or it will create a new sheet with charts. So it's very, very interesting. The next one, serverless web application architectures. So here you have like a real web application, and you're basically creating kind of functionality around your use cases based on functions. We'll look a little bit deeper on that, but it's perfectly okay to implement your APIs as functions, as we showed before that. So you start loading your page, you're calling a function from with HTTP, with REST, and then you're getting the data and you're able to render the whole page. So I think this is very interesting for single app applications. And it's, I think, pattern that we see more and more. Mobile backends, I think similar, but slightly different. So we're taking a picture of our mobile camera. We're invoking, again, like a function with a REST call. With this function, we're uploading dynamically the image to a blob file. Then we're invoking another function that will resize this image. So as you see, like how we have like a very small portions of code that are doing exactly one thing, but we are free to have multiple of them in a chain. Real-time processing. So Azure Functions has very good integration with event hubs. So you can actually enable very powerful IoT scenarios. Like you have like your IoT devices sending a lot of events to event hub. Then you have like an Azure function that aggregates them, that accepts them, and after that, maybe some processing is happening, and you can end up in a SQL database, in a document database, what you want. But again, a very interesting pattern, and because this is scaling based on the traffic, you don't need to think, oh, I have only 2 servers, 2 VMs, what will happen? You just like do the work that you need, and you pay for the work that you did. And something that is very interesting, and probably this will be happening a little bit later in the time, but again, using bots. So, for example, imagine that you have your favorite bot in Skype, Line, Viber, or any other messaging application. You're asking questions to your bot, and actually the bot behind the scene is invoking like Azure function that interacts with Cortana suite, and based on the intelligence that we have over there, it's able to respond. And you provide the response to the user. So now this is the cool part. These are all languages that are supported. C#, F#, JavaScript, Python, PHP, PowerShell, Bash, Batch. And I think this will grow as well. So how it's in AWS?
Python, Node, and Java.
Okay.
That was 3 months ago.
We need Java.
What? You need Java?
Yeah.
Yeah. We'll tell Microsoft. So basically, I'm pretty sure that this will grow. And actually, Azure team, they're investing a lot of efforts in building good tooling and good integration with Java. I see a lot of developments in App Service, which is one of the most popular deployment options in Azure. And now they have like a very good integration with Eclipse. So I hope this will affect this service. I think Microsoft understands that this is very huge opportunity to integrate Java. So I hope this will come. Okay, so a lot of talking. Let me show you like how it looks if you haven't tried, and if you have, we'll have even more interesting discussion. So let's see. So first. I
need to show the content.
Yes. Thank you very much. Let's see. Okay, so this is the Azure portal. The interesting part here is that you'll be seeing your functions under App Service. Why? Because actually, if you come in resource new, and if you go under web and mobile, you see that here in app service section, we have the function app. So function app is actually a container that will contain several functions that are logically related. There is one thing important when functions are scaling. Actually, the actual small functions, they don't scale. The function app scales. So this is also important to think like how you group your functions, because they'll scale as a function app. For example, if in a function app you have 5 functions, they always will scale together. Okay, so now let's return and see. So here under app service, I have like 2 function apps. One is built on dynamic service plan, and another one is built on traditional service plan. What is the difference? Like app service plan is something that was in Azure for a long time. Basically, app service plan maps to virtual machine. When you create it, we know that this virtual machine is for you and you can use it. But because it's a PaaS, you don't have actually real access to the virtual machine. You need to use the tooling and to get some form of access to it. With a dynamic service plan or dynamic service plan, you don't know on which virtual machine your function is provisioned. Actually, the chance that different instances of your function are provisioned on different virtual machines all the time. So let's see what we have here. So for the demo today, I actually have a lot of functions in one function app. I think in a real production scenarios, you need to group them in a little bit better way. But for our purposes today, this will work. So let's start with the easiest one. So this is Hello World. But before that, let me show what is the experience. So this is the experience. Unfortunately, the UI is not very good. Maybe this will be fixed with the release, because we have a lot of nested windows here that you need to scale up and down. But I really hope that this will be improved when the service is generally available. So here, when you decide to create a new function, you can choose the language. So these are all the languages that we talk about. And also there are different classes of applications. So we have core, we have app and webhooks, we have data processing, samples, experimental, and all. So the idea is that, for example, experimental, this is at your own risk. Actually, almost all of them work very well. The only issue that I have so far is I couldn't make work in the SaaS provider example. But apart from that, everything was fine. So let me show you the things that I already have. So see now the big navigation starts here. Okay. So here, this is my Hello World function. Right. Okay. So as you can see here, first we have like several tabs: develop, integrate, monitor, and manage. So develop is where you write your source code. Depending on the type of the function, you have like a functional URL. So you'll be able to invoke this function from Postman or from your web browser. But again, this depends on the type of the function. On the integrate tab, you actually define how your function behaves with the outside world. So what are the triggers? What is the input? And what is the output? And here you can add as many as you want. So potentially it can be triggered by HTTP request, but the input can be a blob or a queue or something else. And you also can output to multiple places. DocumentDB, SQL, or just REST. And here also you define parameters related to the various options that you have, like a trigger, input, and output. Monitor, this is something related to the tooling conversation. This is not ready. And actually, this is kind of difficult, because imagine like your function, maybe it exists only for a fraction of the second. So it's a little bit difficult to monitor efficiently. So I think, and I really hope that Microsoft team will come with something smart, because without monitoring, you don't know like what's going on with your function. This is super important. So this is coming. And manage is where you can like enable, disable the function, delete it. Also, we have like a function app settings. So here is where you say how much memory you want your function to use. So in this case, it's 1 gigabyte. This is of course maximum, right? It won't use it all the time. It will use up to this this amount. If it needs more, it will basically crash. Then you can set up a continuous integration. So if you press this thing, you go actually in the context of app service plan. Where is it set up? So here you can set up Visual Studio Team Services, GitHub, Bitbucket, and so on. So this means that you can develop locally, commit, and then see the changes online. Currently, the local development experience, it's not very good. So I think the team will release it by the end of when the GA comes. You also can configure authentication and authorization. And other things, course, and configure metadata. So here you can provide your Swagger definitions if you have an API. Okay, so this is very high level. Today we'll not go so much deep in the details, but I just wanted to give you like a high level understanding. Hello, good evening. So let's go again back to our hello world. So this is Node.js application. Today we'll show like a different Node.js in C#. But basically, it's very simple code. So even though if you don't have experience with Node.js, please don't be afraid. So basically what we're doing here, very simple functionality. We are getting, we're having a HTTP context. This is the request. So here, from the request, we are extracting query string parameter, name, from the query string or from the body. We are not sure. We support both. And then based on this name, we are creating a body. And we are returning it. This is it. Nothing so much. And here the UI provides a lot of very easy way to testing. So if I provide my name, it will tell me hello Kanyo, because this is what the logic is. Also, for every modification here of the code and every save, we will recompile the code. And basically, it will tell you if you have like a server error. So this is very, very, very simple. But again, the important thing to remember is you have all these different type of functions that you can create. One good way of developing these functions, and maybe the best way for now, is to develop them in the portal. This is a Node.js example. Here you can output a lot of things for debugging purposes. And you can execute them if the context of your function allows you to do that. Okay, so this was like a very quick introduction. Now I'll return to a presentation, and later we return with a little bit more interesting samples. So now let's focus a little bit on C#. I think most of us have a good understanding of C#. Please heard about .NET framework. So in the context of the C#, we have a file that are with extension CSX. In these files, we are writing our logic. So one interesting thing is usually we come up with a notion when we're building a solution that we should have a very nice design, like a classes, dependency injection, unit tests, and this is great, but not in the context of functions. In functions, everything is very simple. What we do in functions, we are just like writing our function, just the minimum amount of logic that will solve our problem. So I haven't read so much about how we do unit tests and stuff like this, but the idea here is different. Like we just focus on the function at the logic 100%. I think like with the time we'll see the same patterns coming with dependency injection, unit tests to function as well. But for now, the notion is like let's take the maximum of it. And also, if you need to define like some data classes for parsing purposes with objects that are coming from queues or a query string or post bodies, you just define them in the same class. This is it. Actually, you have freedom to do more. You can run asynchronous code in pretty much the same way that you do it today in Visual Studio. You just need to have an async keyword. You need to have a task. And this is it. It works exactly the same way. So again, you have like a sync, static task, and you have your code over there. This is it. Here, the cool part is this function, what it's doing, you have like a blob input, you have blob output. But the cool part of this is that you don't need to write any code, like how you open the connection to the blob, how you extract the code of the blob. All of this boilerplate code is taken care of the Web Jobs SDK that is actually the underlying block for Azure functions. So it's as simple as it is. You're just focusing on the business value for your function. Here it's super simple, right? You're copying from one block to another, but imagine you're saving a lot of boilerplate code, like opening the storage account, the connections, managing connection, blah, blah, blah. Azure functions come with some preset configuration. So you have the same notion of namespace. So if you need to use a namespace, you need to basically define it with a using clause in the code. But some of the namespaces are actually coming already installed with you on the system level. So like a system IO, system net, HTTP, and so on and so on. These things, you don't need to include them. They're already configured for you because they're very basic and they're important. If you need to add other framework assemblies, there is a special syntax for that. You start with a pound sign R, and then you provide the assembly name. In that case, you can import like assemblies like the one that are here. Actually, this one also automatically added for you, so you don't need to care so much. So we also have the ability to add NuGet packages. You can imagine that it's very difficult for us to write the .NET code if we don't have like a NuGet packages. So this is the way that we can reference NuGet packages. Again, #R in assembly name. So newtons of JSON, Windows Azure storage, and so on. So these things, and actually also provisioned for you. These 5 NuGet packages, they're part of the platform because JSON is very important, right? You cannot work very well like a service bus. I'm not sure exactly why it's here, but storage also underlying very important part for the system. So these things, they're actually already installed for you. So the only thing that you need to do if you want to use them, you need to specify them with this assembly name. But if you have your custom assemblies, then what you need to do, you need to upload them to the Azure Functions space file system. And again, with a #R, you need to specify the name of the assembly, so you can use it in your source code. So you see that this is a kind of emerging as a pattern. You probably abstract part of your logic. Maybe you have like some proprietary algorithm in this DLL. You upload it, and you just call it in your functions. You don't implement it inside of the function. You have several ways of actually doing that thing. You can upload directly from the Azure portal. You can upload from the Kudu portal. Kudu portal is this sidecar portal that sits next to web app websites, web app services. And also you can use FTP for that. And this is the standard way how you define like a NuGet packages. We need to create a new file that is called project.json. I'll show you very soon like what is the structure of the project. And in this project.json, you're actually defining the NuGet packages by the names that you use them to add them in Visual Studio. So for you, on the fly, when you save, when you create this project.json file, and when you save it, the framework, the runtime behind Azure Functions will dynamically download and install for you the NuGet packages. So the only thing that you need to do is just provide the NuGet package in the right version. There is one specific. Azure Functions work with .NET 4.6. So if you have dependency on something lower, Azure Functions won't be very good fit for you. So I guess one other question that you asked, like how we do configuration. So the configuration is done via environment variables, and we can use get environment variable a method basically to extract the values of this environment variables. So let me show you actually, because there are a lot of new things going on here. So the first thing that I want to show you is, you remember this window, this is our main window, and here you have like a view files. So now we're in the context, let me go to some C# function. So this is the C# function. And here you can see, these view files below the area that you write your code. And here you see actually what is the folder structure files for your function. You have something that is called run.csx. So this is where you write your code. And function JSON is actually where you define the different bindings, like how this function is related to the outside world. This define blob trigger, this define table, Azure table. So it takes data from a blob and it outputs to a table. This is so here we can create the project JSON file that I was talking about, and then over there define the NuGet packages that we need. And the other thing that I wanted to show you, let me see here in the code. I think I should have environment variable. So here you can go to app service settings. This is under the manage screen, and actually here you go in a very much the same context of Azure Web App. And here, actually, under the application settings, you can access the same application settings that you usually define on a web app level. So these are the same values that you usually see from your web config. So you're here basically defining the same app settings that after that you can use in your functions. So all the functions in this function app will share the same app settings or environment variables. So then you can call them with this functionality just by calling their name. So for example, here like a Vision API subscription key, you can specify it here and you can get this environment variable value in your code. So this is the whole idea. Sorry about that. Better to keep it like this. Okay. So another big topic is code reuse. So the code reuse, obviously the functions are very small. And this means that potentially it will be beneficial if you're reusing code. So you have like several ways of doing that thing. But one way is here, it's a little bit small, but here on the top, you can see like an example structure of files for our function. So the idea here is that you can host additional files, like for example, this logger.csx that has a custom function how we log events, and place it in the same folder structure and then reference from the other files. So then you can have like a one file that is encapsulating logic that can be shared by multiple functions in your function app. This is still okay because usually function app will most probably map to a microservice. And inside the microservice is still okay to share. It's problem when you start to share between microservices. But in this case, we are in the context of microservice. Something else important, how we log. You already saw in the window we have like a log window, so we can set a lot of log and debug type of messages, so we know like what's going on with our function. Is it successful or not? There is a little bit strange. The documentation said that we need to name it the variable that is doing the logging. We need to name it log. So I'm assuming there is like some things that are still not very clean on the implementation side, but usually you don't say your clients how they should name their variables.
What's the type?
The type is trace writer. Yeah, trace writer, and the recommendation is to name it log. I really hope by the general availability this will be changed. And also they say that we shouldn't use console write. I'm not sure about the right reasons, but I guess this is the preview effect of the feature. So hosting options, we touched a little bit on that thing. We can host it in app service plan. This is the notion that you have dedicated virtual machines that you already know that they're dedicated for you. This is one option. Then you pay for the virtual machine. It doesn't matter you use it or not. Usually this is good when, for example, in the same app service plan or same virtual machine, you're running a web app or a mobile app or something else, and just your function complements that. On the other hand, another option is to use a dynamic service plan. This means that you're saying, yes, I want my function to be hosted by Azure Functions, but I don't want to be charged for these idle periods when nobody is calling my function. So actually, our functions are dynamically allocated to certain resources based on the availability that Azure currently has. And also, because we have, let's say that we have a lot of traffic to our functions, it's perfectly possible that we have functions running in parallel on different instances, different virtual machines. Currently, we can provision memory from 128 megabytes to 1,536 megabytes. And this is the only thing that we specify when you're creating the functions, apart from the templates. This is the only thing that is related to the infrastructure. This is the only influence that we have on the infrastructure. And because this is dynamic, some of the features that are supported by app service plan, for example, custom domain name and SSL certificates over these domain names are not supported, because you can imagine that this is running very dynamically with virtual machines. It's a little bit difficult to say this will be a custom domain. Development and debugging based on the different scenarios. Most probably you'll be using Postman, browser, storage explorer like this one. This is the free storage explorer by Azure team. And any other, you can write also like your own clients that invokes the functions. Currently, you can live debug from Visual Studio. The same way that you debug like applications that you deploy like web apps, you can do the same way here. Scaling, if you're hosted in app service plan, you need to define your like rules for scaling. Then I/O, CPU, memory will be taken into account when you scale. With the dynamic service plan, there are like some behind the scenes algorithms that define like how the application will scale. Of course, the major criteria is the memory of your functions, both for scaling and for pricing. And the pricing is the other interesting option. So this is how we currently price. In the beginning, when we start Azure Functions, there's like a minimal charge. And after that is based on a meter value. So for example, the memory size in gigabytes by total amount of execution time in seconds. And that's why we come up with a concept of gigabytes per second. So this is the unit of consumption that after that will be there will be a price for this to this metrics when the feature goes generally available. And execution time is the active time for all the functions running the function app. So again, the function app is the entity that is considered for scaling and for pricing purposes. Okay, so now let me show you a little more over the time. Okay, we have a little bit. So I want to show you some of the other functions that are a little bit more interesting. So we saw the one that was just hello world. Actually, the code here, everything is based on the template. So if you go and create it, it will be exactly the same like what you saw here. But I want to show you like a few more that are a little bit more interesting. So let's start with GitHub. So GitHub. So what we can do here. So we have a function that basically will execute when we have like a comment of an issue in a GitHub. So of course, this is a little bit questionable. How useful is this for your enterprise scenarios? But it shows you that you can develop like a workflow involving your like a GitHub, and it's especially interesting if you develop an open source type of solution. You have a lot of people collaborating, open pull requests, giving you feedback. So let's say somebody found a problem with our solution, and they're commenting. So it's very easy integration. You just like getting the function URL, you're getting this secret that is all generated for you, upload them in a GitHub, and then the integration is done for you. So now we'll see what's going on here. Like I don't have anything else from a long time ago. So let's see and add a comment, see what will be the output here. Coming here, have like a just some sample project. Have like a one issue, and I say like a new comment. I would post it. That thing. See what will happen on the Azure function side. So immediately executed, says new comment was posted. So you see, there was like a even fraction of the second, and it's enough, and already we have the output here. Again, this is very simple, very basic. Most probably you don't want to see it here in the logs. Most probably you want to send it to something more meaningful for you, queue, table, or something else. But it's super easy to be configured. Next one, I want to show you something that is going a little bit to more realistic scenarios. So I have two functions. One is called insert task. So here, let's see what we're doing in insert task. Now, this is, you already see, this is like a C#. The previous one was, again, like a Node.js. I didn't spend so much time on the syntax, but this is C#. So you see, now we are referencing some assemblies, and after that, we are using them inside of the code. So what's actually happening here? The very easiest way to see like what kind of function is that, you can go to the integrate tab, and you see that this is actually manually triggered function. There is no input, there is no output. This is interesting, what we're doing here. Insert task, okay, I remember now. So what we're doing here, actually, we're writing to a database. It's manually triggered, so I need to manually trigger the event, and what will happen? First, it will go and from the app settings, from the connection strings, actually, this is the same place that we set the environment variables. We have like a section for connection string. We're extracting the connection string. After that, we are opening a SQL connection, and then we are inserting a few values here. The idea here is that I want to insert like a few values, and I have like a one marker which says completed or not completed. And now we have a function that will basically delete all the tasks that are completed. So very simple, very basic. So let's first run that thing. What we need to happen is here in this data table, we will see like a different type of entities. And we will have like completed equals to 1. So let's execute that thing. It's manually triggered. The input parameter is actually not important in this case. I just used for triggering the function. Here in the logs, you see that function is started and function completed. So this means that here we should have like the values coming. Where are the values? Maybe the other function was just too fast. So let's see the other function. The other function was a clean completed task C#. So let's see what was that one. I think this actually executed. But first, let's see the code. The code is very similar. Again, we are opening connection to the SQL database, and we are deleting all the items that have completed equals to 1. And this is it. The only difference that this is a timer function. So this means that on a schedule, we are triggering this function. Here, this is the standard cron syntax, and basically it says, please execute this function every 10 seconds. So the first 0 here is actually for seconds, and the /10 means you execute every 10 seconds. So, for example, if we change that thing to 0, this will mean execute this function every minute. So this will give us a chance to see actually the values that are inputted. So let's try one more time. First, let's validate that we don't have anything with value 1 in completed section. Go to insert tasks. See, on a small screen, it's a little bit of pain with all this. Let's execute. So this was accepted. Let's see, do we have it here? Yeah, now they came. And because it will be a little bit slower, it will take around 1 minute to execute. We are still able to see them. Let's see. And logs are very helpful. So let's just see what is going on the completed or the cleanup function. So this executed, the time is 9 o'clock and 1 minute. Just interesting timing. Haven't executed yet. Let me change it again to 10 seconds. This is a lot faster. /5. Let's see. Save. Let's see what we have now. Immediately, right? So I think in that case, it performs very well. We have immediate actions. So this is good. So now let's go to the next one. I want to show a little bit of the notion of the polyglot experience. The great advantage of that is that we're talking over REST, or we have different media to talk, like a queues or something else. So we can allow ourselves to have like functions like this one, message creator in Node.js and message reader in C#. So here, let's see like what is this message creator. Basically, this is again a timer function that will trigger here. I said like to be triggered every 10 hours. We'll change that very shortly. But again, just to show you what we are doing in the integrate tab, we have a timer, but this time what we're doing, we're outputting to a storage queue. So this means that we are creating a queue message, and then we are sending it to a storage queue. And all the code that we need is very simple. Again, Node.js. We are defining here one very simple type of POCO object where we are returning object with two properties, message and time. And in the function itself, we have the timer, and we are creating an instance of this POCO object, and we're just assigning the time. This is everything that we do. And on the C# side, we have a function that is listening on this queue. Again, if we go on the integrate tab, the trigger is the storage queue. So when you have a message on the same queue, we're actually reading the message and we'll send it to a storage table. So again, if you write the code in .NET, there will be a lot of things, but because this is based on a web jobs SDK, it's very simple. We have a parameter, which is a queue item. This is the queue message coming. And the abstraction for the Azure table is this iCollector collection with table item class. Here, our queue item is defined that way. And the table item, it's a little bit specified. I'm just adding the time and message column. But it's very, very simple, and we have the original time. This is it. So what we are doing, we are reading the message from the queue, and after that, we start adding rows to the Azure storage table. So let's see how this works. Let's activate the Node.js creator. A little bit speed up. 10 hours is too slow for us. So let's say it will go 10 seconds. And let's see what will happen here. Should start creating messages immediately. I think in the logs I should have like a good logs. You see, they start to come. They're like a sample message. Where is the next one? Yeah, they're very identical, but here you see like it's like a 49, 30 seconds. The next one should be 49, 40 seconds. Yes. So they start to come. Let's see what's going on the C# part. The function triggered, completed. And we see here that the sample message was the text. This is already hard-coded on the Node.js, and this is the date. And if you go in the Storage Explorer, just let me check what was the queue name. If you click on the output, you see the queue name is queue message. So if you come here in the storage account, this is the queue message table. So as you can see, they start to come. Yeah, 37. Yeah, I think they're coming. Here the ordering is not very well defined. Okay, but I think you got the idea. So let me show you a few more scenarios. We'll not spend too much time going into details in each of these, but I just want to show you like different opportunities, and it's actually very easy. I'm very sure that after maybe 1 hour, maximum 2, you'll be able to write these things as well by yourself. And that's why I want just to show like what's available today. So let's go here. Something that is very useful. For example, if you're implementing access to blobs or tables, best practice is to use SAS tokens. So not go directly to blobs that are completely open to the world, but to have SAS tokens that allow you to have authentication. Generating SAS tokens in .NET, it's let's say like maybe 15 to 20 lines of code. Here, it's a little bit less. We have like a predefined template how we can do this thing like very quickly. The SAS token is actually appended in the end of the blob or table request and actually authenticate you in front of the storage server service, so you can interact with it. So this is the code. Yes, see, now I'm navigating on 3 levels here. But basically, I haven't changed the code. This is part of the template. The idea is that this is very useful because it will allow you on the fly immediately to create these SAS tokens and to provide them to another services. So, for example, your continuous integration build server or something else, any external service that requires SAS token to talk to your blobs or tables can use Azure Functions to generate that thing. And it's super simple. Like you have this template if you need modify it a little bit, but apart from that, it generates for second what you need. Okay, and this is your SAS token here, starting from here, and you just need to append it behind your blob URL. Here you have like the URL. Okay, this was nice. And next one, let me show how easy it's actually to send email. So again, we will use like a polyglot experience. We have like Azure function in Node.js to create a message on a queue. And then we have like a C# function that will actually read this message from the queue and send email. Okay, so let's see first. This is the Node.js function. This is pretty much the same stuff. We'll get like some kind of a request. In the request body, we have like a little bit information, like a number, name, and email that we use actually for creating the email later. And we're taking this information from the request. We are creating a queue message, and we are sending it to the queue. Basically, just passing this object to our output queue item. This is a variable that maps to our queue behind the scenes. That is defined actually here in the integration tab. So see here, output queue item is the same thing that we actually interacting here. So this means like I pass this object to the queue or push it to the queue. Is that simple? Because actually there is a lot of plumbing going behind the scenes that are done for us. So let's see here was this is okay. This was a request type of function, so I can execute it from here. So I have like a sample object. This is my name. I have like some fiction, like a sample number for my order. The idea here is that I'm getting order confirmation email, and I'm providing the email that I want to get email sent. So I can run that thing. This says okay. So here a little bit I have a log message. So this was the message that was sent to the queue. So now let's go and what's going on the C# part. So C# part is listening on the queue, and it actually it was triggered and it was executed fine. I think yeah, this was the time just like 40 seconds ago. So now the next step is to see do we have the message. It takes a little bit time. This is like integrated with SendGrid. So if we go here, I can see what's going on the SendGrid level. And SendGrid is very cool because it gives you around 20,000 emails free per month if you provision it in Azure, or more, maybe even outside, but for Azure, definitely you have these mails. This is the telephone number. So they're giving a sign that we need to leave at some point. For now, let's continue. Hi. I think it's okay. We can continue. I don't have so many demos left, so I think we'll be finishing very soon. So this is the SendGrid portal. So here we can see like what is the current situation. So I requested a mail to be sent, and you see actually they sent that they said that it was delivered. Let me just see what is the time. Is it like a UTC or
It's the US time.
US time? Yes. So let's see. Maybe I already got the email. Yeah, I got the email actually too. So yeah, this works. And again, it's super fast, right? Of course, here we have dependency on SendGrid, but again, it's in milliseconds, creating from a Node.js, going to a queue, reading from queue, sending from SendGrid, and receiving the email. So very, very fast, very, very scalable. Okay. And what else I have? The next one is really cool. So the next one is actually what we're talking in the beginning. We are breaking API methods in a different function. So here we have, the notion is here that I'm creating like a people or person in my API, and I have like several functions that are actually behind the scenes are interacting with a storage table as a data source. So where is this thing? It's here. Okay. So here, this is my get function. I'm referencing the storage NuGet, the storage assembly, sorry. And after that, what I'm doing, I have like a request method from the standard HTTP request message. I'm retrieving information that will allow me. Actually, I'm not retrieving everything, anything. I'm just like getting all of the items that are in my Azure table, and after that, I'm inputting them. And the only special thing that I'm doing is I want to define like a name property in Azure table to hold my name. Pretty much, I'm doing the same things for the item that creates an person in my data store. This time I'm retrieving information from the request, and I'm creating basically a new person. And after that, we have one more for modifying, based on the row key and the partition key. I'm modifying the existing person. So for that, it's a little bit easier to show you here. So this is again the same URLs for Azure functions, and you can invoke them from Postman. So you call it, and you get all of the people that are defined in my data set currently. I can create a new person. So here, this is the post method. Okay, this is my test person. Send. Azure function execute, and now it's created. So let's see, do we have test person created? Where's that? Yeah, it's here. Test person is created. So now, if I remember, I also can update it. Let's say I want to No record. I want to update one of the records that I have. Let's see, was it updated or not? Yeah, it's updated. So you can see like we have like a normal API with all CRUD operations like Azure functions. Of course, this is like a very simple and basic scenario, but you can imagine how you can a little bit enhance. You have like a little bit of code sharing. Maybe even you have like your logic that you can share in a NuGet package or another class. But again, these give you a lot of freedom because you can change Get completely independently from anything else and scale it completely independently. Let's say that your API is read heavy, then Azure functions for you scale only the Get operation. But the put and post will not be affected so much. Okay, and I think I have just one more. I think this is also fun. This is, where is that thing? This is face locator. So basically, this is fun because it retrieves an image. You see here like a stream image. And what it's trying to find is there is a face inside the image. Here we are relying on external API. This is like a project talks for the APIs. These are the APIs that Microsoft expose in terms of working and analyzing images. So of course, I don't have this functionality developer myself. I depend on this Oxford APIs. The only thing I need to do is to register for these APIs and provide my key that is defined in these subsettings that we showed before that. And I just code the API, provide the image, and it should tell me, do I have a face in it or not? So let me very quickly show you how this thing works. But before that, again, this is a trigger based on a upload of a new blob, and it will input the output to a storage table. So my blob should be inserted in a container with name images, and it will listen for every image that it's uploaded over there. So let's go very quickly. We have a blob container. We have like a container images. Yeah, these are my test data. Let me delete these things and upload. So I have one image without face. This is just a map. We are uploading that thing. Let's see what's happening on the function level. So here in the logs. So the function successfully executed and says faces empty array, nothing. Let's try upload, oh no, this one. This one. Let's upload image with face. This is uploaded. So now we're waiting for our function to execute. Take a moment. Yeah, it executed, and then it says this is 23-year-old person, female, and this is the face rectangle. Of course, Oxford API is smart. It's not my function, but again, you can imagine when you need to depend on other external services, this is the pattern, right? You just take what you need and you integrate it in your Azure functions. And there is like one more that I want to show you. This is image resizing, basically. Here we depend image resizing. It's written in C#. Here the cool part is we actually depend on an external NuGet package, which is called like image resizer that works with IIS. So here, do you remember that we were talking about this project file where we define NuGet packages? So this is exactly what we do here. We say like I'm .NET 4.6. I have one dependency. It's called image resizer. This is the same NuGet package ID that you use in Visual Studio, and you provide the version. So then what will happen here, this function is basically listening exactly for the same events like the previous one. When you upload a blob file to a container, it will trigger the function code, and will output to two different containers for small and medium images based on the resizing. So let me see which container was that. So we have sample images. So we are listening into sample images, and we are outputting to sample images medium and sample images small. So let's go here, sample images, And let's upload our face. This is relatively big picture, so it should be fast. So let's see what will happen on the function level. Going back here. Let's see what's going on in the logs. So what's that time? Yeah, I think that's the function already executed. So this means this is the name, like it's a little bit strange name. So yeah, we already have the image here. This is middle size images, and this is like small size images. So let's just check very quickly, copy the URL, try to open it here. No, not very good idea. We downloaded it. Let's open it here. So it should be this is the small one, I think. And the other one, no, this was the middle one, and this should be the small one. So you see there is a little bit of difference, right? So they're both resized, but again, you saw like everything happened in a fraction of a second, so it's very, very fast. Okay, so this was a lot of material that we covered. Thank you very much for your patience. I hope that this topic is interesting. I really advise you go and play with these things. They're very cool. It's a little bit early to go in production with them. There is no SLA, but it's very, very powerful. And I think when you start thinking like how you can break your current workflows, development pipelines, it can become really, really powerful because interaction with storage is greatly simplified. Interaction with event hubs very simplified. What else? DocumentDB, SQL, very, very simple. So you reduce your code, you have like a very single responsibility, very focused type of coding that gives you a lot of freedom. I think still we need to see a little bit of design patterns that evolve from around this serverless approach, but I think a lot of people are very, very confident that probably this will be the future development in a cloud. I don't believe that this will apply to everything, but to big part of the application, for example, APIs, maybe it will be a very, very good solution. The Azure team that currently develops the functions, they don't recommend going like a full-blown microservice approach with Azure functions because still the tooling is not there. They recommend using Service Fabric for that. But I think after some time, maybe this will be very, very, very interesting way because with Service Fabric still you need to manage a cluster. You need to be a little bit more knowledgeable. Here it's very simple in terms of configuration. Thank you very much. It was a lot of content, but I really hope that you learned something new. Thank you, guys.
Thank you.
Okay. So
this is the C# function.
Yeah, obviously there's some kind of delay.
And here you can see.
Okay, let's stop
You
this.
see these view files below the area that you
What will happen if it's all
And here you
delayed?
see
Like
actually what is
if I stop now,
I can,
folder
you can
structure.
stop
Files
now
for
in
your
the
function.
other
You
screen.
have something that's called run.
Other's
Yeah,
handout,
CSX.
the third page.
So this is where
This
you
one.
write
Yeah,
your
the
code.
second, stop broadcasting.